Hey class, welcome to our session of sketch notes here. I'm going to take the opportunity to hopefully present this whole air pollution unit in a visual way as a quick reference back. So you should have a table going over all the causes, concerns, and solutions completed by today. It would be helpful if you had that table out with you as we got started on our sketch notes. A couple of things, just kind of as sketch notes, we're just going to set the stage here. We got to kind of basically create our environment. So we're going to give ourselves a little rolling hills here. We're going to include a road, a volcano, clouds, trees, sunlight, all the stuff that we're going to need to complete kind of what we're doing and how these pollutants are coming to be. Okay. So what we're looking for is a nice road here. We're going to add a car on that. We're going to make our volcano. So we got to have all this stuff in our environment here so that we can add all our air pollutants a little bit later. So we can put our smokestack over here. All right. We get a nice tall smokestack. Taller than the volcano. Holy cow, that's going to produce a lot of smoke there. This is our coal plant. All right, so people come on into the coal plant here. So understand that this is going to be a primary source for us for pollutants. We're going to add some clouds up here. We need our favorite tree. Hopefully we got our Lorax all under wraps here. You guys have all had that Lorax before. Video, hopefully you've seen that one. Basically, I'm going to go ahead and add in, just kind of in a circular pattern, the tuft of the truffula tree, these little, it's like a weird looking pink palm tree. All right, so we have that. We are going to need to have a factory made over on this other side here. We can go ahead and add our factory like, we'll call this our CFC factory, okay? That's where we're going to get those out of. And we'll come back to those later. So we have our coal burning plants. We have our CFC factory. We have, by the way, factories aren't just making CFCs, but they're making products like aerosols and foam insulations that produce CFCs. We do need to add sunlight. We have our tree, volcano, clouds, road, and we'll also need a fossil fuel burning vehicle. All right, so let's add our sun over here. That's going to play a factor in a lot of our secondary pollutants. So don't forget to make your sun look super cool, or at least this cool. All right. And car, we need a car over here. So we go ahead and add our car, kind of driving down the road. So go ahead and put some tires there. Exhaust pipe's going to be kind of important in this. And then we're going to add these are sections of pollution here. Okay. So that's where we're going to put our primary pollutants as we go through our list. So we kind of have a stage set for everything going on. Now we're just going to kind of go step by step through our primary pollutants first. So hopefully you identified those in your notes. The first primary pollutant we're going to talk about is nitrogen oxides. Nitrogen oxides are NO or NO2, so we just kind of abbreviate them very generally as NOx. Those come from vehicles. Okay, so that could be NO, nitrogen monoxide, or nitrogen dioxide. NOx is our first primary source, right? So combustion of fuels. Fossil fuel burning power plants, same thing, NOx. Okay. Moving on to our next major source is sulfur dioxides. Sulfur dioxides come from a natural source of volcanic eruptions and our other source, which is coal burning power plants or refineries too. All right, so sulfur dioxide. That's our next major primary pollutant. Following that in our power plant or our coal plant would be things like lead and mercury, our heavy metals. So we'll kind of put those two together. Those are on your chart also, lead and mercury. Okay. Remember those heavy metals get into our ecosystems through wet or dry deposition and have the propensity to bioaccumulate in organisms' fatty tissues. So we talked about that happening with our tuna as an example. Okay. Carbon monoxide is another one. CO is produced from motor vehicles. Add another one into the car. Oops. Sorry, just CO for now. CO2 will be there later. And power plants burning fossil fuels, kerosene, or wood burning stoves too. So carbon monoxide is there as well. Okay. As we continue to move on for our primary pollutants, we're going to get into VOCs. That's a volatile organic compound. These are things that are going to basically be present in our environment by evaporating into the environment very quickly. They're very volatile. And so things like gasoline and paint, and basically they have that strong chemical smell to it, those persist in the environment and can get into our atmosphere fairly quickly once they're exposed to the air. So VOCs have many sources and there are many different types, but gasoline is going to be one, car emissions another. So put VOCs in the car emissions, just the gas stations themselves. We're going to have this too. And our trees, actually, I'm going to put trees here. Isoprene, there's a natural source. VOCs as well that could occur there. Okay, so there's so far man-made, gasoline, and natural source as well. Moving on to the next one, carbon dioxide, CO2, probably the most talked about pollutant from burning fossil fuels. CO2 comes from the burning of pretty much anything. So CO2 here, and finally CO2 for our car as well. We could even put CO2 if we had a forest fire or something along those lines. So if we, engulf this poor truffula tree, man, they haven't been through enough. Now they're on flames, right? So now this thing's on fire. Forest fire is going to produce CO2. So there are natural sources of these gases too. It's important to know where they come from, both anthropogenic, human caused, and natural. The next ones we're moving on to are non-methane hydrocarbons. There are many different types of those too. So hydrocarbons, I'll go ahead and make those guys a pink color here. Non-methane hydrocarbons are going to come primarily from fossil fuel burning. So these hydrocarbons are going to be present in our factories. So non-methane hydrocarbon, NMHC. We can also get them from our vehicle as well. So we have those two present. These have the propensity to increase greenhouse effect. If we reduce our fossil fuel use, improve catalytic converters, or make sure they're installed in all cars globally, we can reduce these by a great deal. The next thing we're going to cover is particulate matter. This is a really general category. There are more specific types of particulate matter settled on size. We'll just put them as PM. Natural source could be a forest fire, so we'll add particulate matter here. Could be a volcanic eruption. More than likely it's the burning of something. So if there's CO2 attached, probably has particulate matter associated with it. Diesel engines are particularly worse. So a big diesel truck would give off more particulates than a standard car. And then obviously something natural source like the forest fire or just wind-blown dust would be examples of particulate matter too. CFCs coming out of our factory here. So we can add our CFCs over here. So CFCs are coming out and being released into our environment. As this happens, the CFCs are going to degrade our ozone. So now we're moving into some of our secondary reactions. In this case, the CFCs are going to react up here, way up high with our stratospheric ozone layer. So this is the troposphere. So I'm going to go way up here. We're way up in the stratosphere. Okay. So we have ozone is O3. Remember, ozone was formed by oxygen, and then there's free oxygen, and the oxygen and free oxygen are going to be driven together through light. Right? So the light causes this reaction and creation and formation of stratospheric ozone, and then our CFCs are going to lead to the destruction of that ozone because one of the chlorines is going to break off, and it's going to find this ozone, and it's going to break off, find this ozone, and then it's going to end up splitting the ozone apart into essentially a chlorine monoxide and oxygen molecule. All right, so this is where we get the ozone hole from. So this is our formation of ozone, and this is our destruction of ozone. So we get this chlorine kind of breaking off. This is why these CFCs are harmful and dangerous. The other things we need to address here would be tropospheric ozone formation. So ozone, good up high, bad nearby is kind of our saying, right? So it's good up there, protects us from ultraviolet light from the sun. That is harmful to ecosystems, humans, skin cancer, sunburns, all that stuff. Tropospheric ozone down low can cause respiratory issues. We definitely don't want tropospheric ozone present by us for eye irritation, lung damage. It's just not great in general. So how is tropospheric ozone formed? We'll go there, tropospheric ozone, and then I'm just going to show you kind of like where this comes from. So basically, tropospheric ozone is going to involve our VOCs. All right, VOCs plus NOx's. All right, so the NOx was our orange. So those are the two primary makers in this. All right, the only other thing we need to drive this forward is some of this ultraviolet light or sunlight to move this forward and make our tropospheric ozone. So we don't want it down below. We don't want to be breathing it in. We want it up high in the stratosphere, not in the troposphere. The next thing that we need to have is discussed is going to be photochemical smog. All right, so smog or photochemical smog. Okay. How is smog formed? Well, smog is really more of a mess. It's more of a mess because it's all these primary pollutants. So you have things just like the first two. We have VOCs, and we're going to add in our NOx, nitrogen oxides, and then we can keep adding stuff in there. Ozone, in particular, the tropospheric ozone we had before, is going to be something that could be added in. Just various hydrocarbons, so the NMHCs, let's pink here, NMHCs get added in. And all this stuff ends up creating smog when combined with sunlight. So same thing, sunlight, and then we're gonna create just this mess, smog. There's no chemical formula we can give for it. That's worth doing. You know, this is just a big mess of pollutants. Finally, we have acid rain. Okay, so acid rain can happen a couple of ways. Basically, combustion of fossil fuel is releasing sulfur dioxides. Okay, sulfur dioxides are going to go up here, and they're going to react with the water vapor in the air, and then what ends up ultimately happening is we get rainfall in the form of something like H2SO4, which is acid rain. Okay? So that's one example where we get, you know, SO2 plus H2O. Okay, so there's our acid rain for one example. Another way that can happen would be our nitrogen oxides, our NOx's, doing basically the same thing. Right, those come there, and now we can also get, I think it's HNO3 is our next one. So we have that equation down below, and you can kind of see that the sulfur dioxide and nitrogen oxides are going to react with water, and then they're going to create an acidic substance that's going to rain down into our environments. Obviously, acid rain is an issue for our ecosystem health by lowering the pH and creating more acidic environments that organisms aren't well adapted for as one big ecological issue. So hopefully you can see the different pollutants outlined, labeled, and a better reference for you. Particularly focus on understanding the secondary pollutants and how they're formed. You know, where the primary pollutants come from and how the secondary pollutants are formed. Hopefully this was helpful. Please let me know if you have any questions as you guys work your way through.